This is the reason behind our existence. The reason behind the existence of everything on earth. Without it, there would have been no life, no earth, no planets, and not even the solar system. The sun was born about 5 billion years ago. Since then, it has been burning its nuclear fuel to produce energy. The energy that keeps us going. But like everything on earth, even the sun cannot live forever. It will eventually die. But what will happen when it reaches its end? Will our sun become a black hole? And how much more time the sun has before it dies? This is Q&A, and here is the answer to the question, how will the sun die? To see the future of the sun, we need to first understand its present. You may wonder, if the sun is so big, why doesn't it collapse inwards under its own gravity? Well, it is collapsing every second, but this collapse is halted by pressure from the nuclear reaction in the core. The sun's core is converting hydrogen into helium at a whopping 15 million degrees. The pressure from this reaction is perfectly balancing the gravitational collapse, and as a result of this balance, the sun is in a very stable phase. But after 5 billion years, the supply of hydrogen will be over and it will be left with the helium core. Now this is where the problems start. Remember, we had a pretty good balance in the beginning? That balance is now disrupted because there is no nuclear process going on. Why? Because the next fusion reaction, helium to carbon, requires a temperature of 100 million degrees, which is not there. So the core of the sun starts collapsing as gravity gains the upper hand. Now that's the inside story. Outside, sun has become a red giant star. It is increased in diameter, swallowing Mercury, Venus, and reaching the edge of the earth. You might think that the story is over. Gravity will now collapse the sun. But this collapse actually proves to be a blessing in disguise. With time, it increases the temperature of the core, and within a few thousand years, it will reach 100 million Kelvin. As soon as it will reach this mark, the core will reignite with an explosive event known as the helium flash. This explosion will produce as much energy as sun did in the past 10 billion years. Now the core starts fusing helium into carbon and will do so for the next few million years. Outside, it will further increase in size and will ultimately swallow the earth too. One day, all the helium will be converted to carbon, and again the core will become inactive as carbon fusion requires a temperature of about 500 million Kelvin, which, just like before, isn't there. Sun isn't big enough to host a full-scale carbon fusion, so now the core cannot save the dying star as earlier. It might look that gravity will now collapse the star to nothing and beyond, but this is where the electrons come into picture. The role of electrons is very easy to understand. Let us use a common life analogy. Suppose a cousin of yours whom you don't like at all visits your house. You hate being together. At night, your parents send him to your room to sleep with you. You will naturally resist being with him and rebel. This is what happens inside the star. The electrons are the cousins, room is the quantum state, parents are gravity. Electrons hate being with each other. That is, they are fermions and obey Pauli's exclusion principle, so no two electrons can be in the same state. As gravity tries to crush the star, electrons will start occupying all the quantum states available. They will start repelling the force that tries to crush them into the same quantum state. As a result, a new outward force has been created by the electrons that halts the collapse, which in the analogy is the rebel by the cousins. The outer layers of the sun are blown, and what is left behind is the exposed core known as the white dwarf star. The most interesting thing about it is that even a teaspoonful of its material can outweigh the heaviest object on Earth. This white dwarf star will radiate all its energy over the course of trillions of years until it becomes invisible to the equivalent of the naked eye, a black dwarf star. Due to its small size, sun will not form a black hole. It will ultimately form a dead star, a white dwarf. But there is no need to worry. All this will happen after 5 billion years, and by then, who knows, we might become intergalactic species. Share this video with your friends. See you in the next episode of Q&A.